In this video, we're going to talk about some more examples of domain and range, specifically when we have more unique functions or graphs where there's maybe an asymptote or it's a piecewise function. So there's multiple components to our domain or range. So in this first example, these red dotted lines, those represent asymptotes, which means that the graphs are going to approach, never quite get to those values. So this vertical one, if we think about our x values first for domain, these graphs are similar to what you might see on a graphing calculator, where they aren't going to actually have arrows at the end. So if the graphs go to the end of the screen, you can typically assume that it's going to go on forever. So as we go to the left, the graph goes to the end of the page. Doesn't really look like it's going to end at all, plus it has its asymptote here. So we can just assume that x goes to negative infinity to the left. To the right, as we go along our x-axis, I'm actually going to use a line here. It's kind of nice to use that visual. So as I go across from left to right on my x-axis, you see my orange line is touching the graph here, but then once we get to x equals 1 right here, we've now come right up to that asymptote, that vertical asymptote. So that tells us that x is never going to equal 1 within this function. So it gets really close to 1, but doesn't quite get there, and then it starts up again, and x can be greater than 1, and it goes to the end of the page, so it goes towards infinity. So we say that x is less than 1, but not equal to. X is greater than 1. And another component you need to know for interval notation is if there's two components or more, we use this symbol here for union. So that tells us that our domain includes anywhere from negative infinity to 0. But remember, the parentheses means that it doesn't include that value. And then anywhere from 0 to infinity. So it's basically all real numbers except for 0. And so these two components here combined with the u, if it's simply an asymptote, should match up. Then for our range, I'm going to flip our line here. Always go to minimum first. So as I go down on my y-axis, this graph is going to go down forever. Actually, both pieces end up going towards negative infinity. And then as we go up, we see that our orange line is always touching the graph. And that's because this asymptote is a slant or oblique asymptote. It's not horizontal. And so there's some y value from negative infinity to infinity that's included at some point on our graph. So that just ends up being all real numbers. For this next example, so we've got a piecewise function, so we have to consider all components. So our domain, remember as we go to the left, let me get my line here. Okay, so our line, oh man, the mouse is not working right now. So along our x-axis, as we go to the left, even though it looks like it's going up and it's not going to get to some of these values, there is an arrow as we go left, so that goes to negative infinity. And now this first component goes up to 1, and that's a closed circle. So that means that 1 is included in our domain for this component. And then we jump up to this piece. This open circle tells us that 1 is not included. So if both of these points were included, that would not be a function because our x would repeat. So it goes from negative infinity to 1 here, and then it goes everything greater than 1 but not including 1 to 2 here, and then it jumps down here, so everything greater than but not equal to 2 to infinity as we go here. So We could have 3 separate components here, but as we continue on, it jumps right from 1 to greater than 1, and then from 2 to greater than 2 without really missing a beat here. So it ends up being all real numbers for that example. Our range, then there is a minimum here. It doesn't go below y equals 0. And then as we increase, these other 2 components don't matter because this piece right here goes forever as we increase on y. So y is greater than 0. This should be or equal to. So I'm going to quick change that. Y is greater than or equal to 0. And so in interval notation, we just say from 0 to infinity with a bracket on 0. Last example, another piecewise function. Now we don't have the clear dots that we did right here at the end of our pieces, but since there's no open circle, we can assume that it is included there. So our domain, we go, if we count each line here, this is at -5. So this piece goes from -5 to -3, and then -3 to about 1.5, and then 1.5 to 5. So it's continuous as far as our domain from -5 to 5, so we use the brackets. And then our range, the lowest point is right here at y equals 1. And so it goes from y equals 1 up to y equals 3. And then there's nothing from 3 to 4. And then we see that we have y equals 4 here up to, we'll just assume that goes up to 6. And the range of this piece is included in this piece, so I don't really need to focus on that. So the range again from 1 to 3, and then again from 4 to 6. So we have those 2 components. And so we have 1, 3 union 4, 6 as our range.